Hi and welcome to this video on using Versile Platform for making peer-to-peer connections. On the internet it is often challenging to establish direct connections between two peers because their respective addresses may not be known or they may be behind network translation. And one way to address this is by using some type of relay service to help mediate the connection, negotiate the connection parameters, and this is essentially what is done in services such as Skype or with torrents. And in order to connect peers which may be behind network translation, such as routers, is use a technique called hole punching, which you can look up more information, for instance, on Wikipedia. The Versile platform has supporting functionality for making relayed connections. It defines a number of data types that can be used together with the relay service. And it defines a UDP-based transport, which can be used then for running higher level protocols over UDP-based connection between a client and server. And it is useful to use UDP in a peer-to-peer setting because it works more reliably with routers and network address translation. So let's look at what the overall process looks like when a Versile platform and a relay is used for making a connection. So there needs to be a relay running. This is fairly straightforward to create based on functionality that exists in Versile platform. And when the relay service is running, a server can connect to the relay using whatever method interface has been created on that relay to register a service and to send an acceptor object associated with that service. And that acceptor object can be used later by the relay for making callbacks whenever a client wants to connect. The relay and the server is then in a setting where they are essentially listening for client connections. The server maintains a link to the relay for receiving callbacks whenever a client attempts to connect, and the relay must be listening for inbound VoP connections for connecting clients. When a client wants to connect, it sets up a link to the relay where it requests that particular resource which the service has been registered as, typically as a URL which identifies it as a resource. The relay verifies the service exists for that resource name, and if it does, and it believes it is authorized to inform the client that such a service exists, it returns a UDP relay object to the client. This allows the client to see that there is a relayed service associated with that resource by checking the type on that return object, and it can use that object for later initiating a connection to that service. If the client decides it wants to proceed with a UDP-based service connection, it makes a connect call on the received relay object, which instructs the relay to facilitate the connection. The relay then contacts the server on the acceptor object that it has associated with the service and requests client access, providing client IP address and any other client credentials registered with the relay in the process, which the server can use for making a decision on whether to accept the service. Assuming the server wants to allow the service request, it passes a positive result on the service accept request, where it includes a UDP connector object that will be used in a follow-on service handshake. The relay then sends UDP handshake details to the client and indicates that approval was granted. And by sending approval and by receiving approval, this also implicitly instructs client and server to initiate the next step of a handshake, which is to the datagrams to the relay with some tokens received by relay and sending to a UDP interface that was published by the relay, whereas the relay starts then listening for such incoming datagrams. So the client and server starts to periodically send datagrams to a known network interface on the relay. And this is done in order for the relay to discover the external internet-facing UDP addresses of a socket that the client and server will be using for making a peer-to-peer connection. And as UDP protocol is not reliable, datagrams may be dropped. The client and server needs to periodically resend datagrams until the relay has received the datagram and indicates it has received datagram, which is thus by making a callback to the connector object of the client and server respectively. And thus this then over the already existing VOP link it has to those pairs. When datagrams have been received from both client and server, then all information exists that is required to initiate the direct connection. So the relay instructs both the client and server via the connector object to proceed with setting up a UDP transport to its peer, and then informing both the client and server in that process of what is the UDP address. So the internet side UDP address it should use to connect to the peer. The client and server then attempt to initiate the UDP transport connection directly to its peer. And what is very important here is that each side has to reuse the same socket that was used to send datagrams to the relay for communicating with the UDP-based peer-to-peer connection. This is in order for network address translation to also then reuse the same public interface for this second connection. Assuming that connection is successful and the client and server are able to discover each other, they now have a VUDP transport channel enabled, and typically the client and server will want to then initiate a Versile Object Protocol link over that transport in order to make remote method calls over VOP. So this would be a regular VOP link handshake, similar to how it is achieved over TCP, after which the peers have effectively a VOP link established directly between them as a genuine peer-to-peer connection where all data is passed over the network directly between the peers, and the relay is no longer involved in the link communication between client and server, which has the obvious advantage that for bandwidth usage on the relay only sees network traffic related to the initial service discovery and negotiation of a peer-to-peer connection. And also with respect to privacy, as client and server can communicate directly without the traffic being observed by the relay as a third party. For more information about the related Versile Platform specifications and APIs of implementations, you can go to versile.com, and we will now here make a small demo of how this works in practice. So for this demo we have a simple relay service set up, which is running on localhost. It would work just as well to have it running on the internet and to have a server and client behind network address translation, but here we run everything locally. We have set up a simple code for a simple test server, which has two main components. It has a class for an approver object, which is sent to the relay when registering a service, and a few lines of code to register that approver as a service handler with the relay. So as you can see, very little code to actually set up a relayed service. We have set it up here with some logging, so there will be a little debug logging output as it runs. And we will connect to this relayed service with a test client, which is also a very small amount of code here using Versile Python. What it does is it makes a VoP connection to the relay to obtain then a UDP relay object. It uses just one line of code to initiate VoP over the UDP transport connection for that relayed service. So basically everything we went through in the previous slides is achieved just by this one single method call on the client side, and it makes a remote method call on the gateway object that is received from the relayed service. In this case, just passing a string and receiving that string back, printing the result. So when we run this, a relayed connection is set up. You see that there is logging activity both on the relay and on the relayed server. And the method call executes just as any other VoP channel. So we hope you found this to be useful information. For more details, you can go to versile.com, and thank you for watching.